This is the AQA Further Math Level 2 2024 June paper 1, the non-calculator paper. Alright, let's crack on. The square root of t over 20, replacing t for 2.42 times 10 cubed. And calling 22 times 10, I can divide the 2.42 by 2 and divide 10 cubed by 10. Gives me 1.21 times 10 squared. 1.21 times 10 squared is 121. Root 121 is 11. Difference of two squares factorization, x plus y, x minus y, for question 2. Question 3, 3n divided by n is 3. So it's going to tend to 3. And then if we work out the gradient of the two lines by turning the lines into y equals mx plus c format, we can see the gradient of the first line is 3. And for the second one, dividing both sides by 6, we can see that the gradient of the second line is also 3. And the same gradient for both lines implies that they are parallel. Question 5. First thing I'm going to do is turn it into something friendlier to differentiate. So I'm going to rewrite the equation as 4x to the minus 1 plus x cubed, and then differentiate it bit by bit. So multiply by the power, subtract one from the power, we get minus 4x to the negative 2 plus 3x squared. That would be perfectly acceptable as an answer. I've changed the minus 4x to the minus 2 into minus 4 over x squared, although that's not necessary. Minus 4x to the minus 2 would have been sufficient. Question 6. The midpoint of AB. Here I'm searching for the centre of the circle. The midpoint comes out as 0, 0, so the circle is centred at the origin. And then the distance of either point A or B from the origin will give us the radius. So a bit of Pythagoras, square root of 12 squared plus 1 squared, square root of 145. And that tells us the radius is root 145, so the equation is x squared plus y squared equals 145. Question 7, matrix multiplication. Well, carrying out the operation 4, 0, minus 2, 3 on xy gives us minus 8, 7. And looking at the calculations, carrying out the top multiplication 4 times x plus 0 times y equals negative 8. So 4x equals negative 8, x must be negative 2. And then carrying out the bottom calculation, minus 2 times x plus 3 times y equals 7. We know x is negative 2, so I can substitute that in. 4 plus 3y equals 7. 3y equals 3, y equals 1. X equals negative 2, y equals 1. We've got an equation equal to 0, so first thing I'm going to do, spot that we've got x's in each part. If we factorise an x out as a first step, it gives us a quadratic. Quadratic factorises to 2x plus 1x minus 5. And therefore we can read off the three solutions here. X equals 0, x equals negative a half, and x equals 5. Question 9, Pythagoras in 3 dimensions. You can do this in 2 steps, but I prefer to do it in just one. A squared plus b squared plus c squared equals d squared, if you like. So we're square rooting 3 squared plus 12 squared plus 4 squared. 9 plus 144 plus 16, which is the square root of 169, which is 13. AG is 13. Question 10. Well, we know they meet at this point P. So the x-coordinate of P has got to be 2. If I substitute 2 into the first piece of the function, we get 20 out. So the y-coordinate of P, if you like, is 20. and I can use that, substituting 2 into the second part of the function, to construct an equation involving a and b. So substituting 20 in for sort of the y coordinate and 2 for the x's simplifies down to 10 equals 2a plus b. Then using the other point q, x is 6, y is 12, substituting the 12 in for the y and the 6 in for the x gives us a second equation in terms of a and b. Reduce that down, 2 equals 6a plus b, and then we're just solving a simple pair of simultaneous equations. Eliminating b is very easy. We'll end up with minus 8 equals 4a, therefore we know a is negative 2. And once we know negative 2, we can substitute that in to work out that b is 14. So a is negative 2, b is 14. Question 11. So I just factorise cubics. You can work it out one step at a time. If you want to do that by long division, you're absolutely welcome to. I prefer to save ink and just factorise it out, work out each bit one step at a time, and we get x squared plus x minus 2, and that factorises to x plus 2, x minus 1, and so the other two factors are going to be x plus 2 and x minus 1. For 11b, we can use the factor theorem. We know that if we substitute 2 into the function, we will get 0 out. So I'm going to substitute 2 into the function and equate it to 0. Go through each calculation. 16a minus 24a plus 10 minus 22 is equal to 0. Collect the a's, bring the numerical parts onto the right, divide by negative 8. Simplify a is equal to negative 3 over 2 minus 1.5. Question 12. This is a cosine rule. A squared equals b squared plus 2 plus c squared minus 2bc cos a. A and b are 12 and 10. Doesn't matter which way round you assign them. And so our BC in this case will be the square root of 12 squared plus 10 squared minus 2 times 12 times 10 times cos of a. It gives us cos of a as being 3/4 in the question. So we can replace cos a with 3/4. 12 squared is 144, 10 squared is 100. 2 times 12 times 10 is 240, so it'll be 240 lots of 3/4. And now we're just tidying everything up. 144 plus 100 is 244. 3/4 of 240 is 180. Difference between 244 and 180 is 64. And so BC is 8. Question 3. Split this up into two separate rectangles. The area of the left-hand rectangle is going to be 7 times x. The area of the right-hand rectangle is going to be 8 lots of x minus 3, and the sum of those two areas is going to be less than 51. And so if we solve this inequality, we can find the upper bound for the value of x. The lower bound for the value of x comes from the fact that one of the lengths is x minus 3. We can't have a negative length, so x will have to be greater than 3. And so 3 is less than x is less than 5. Question 14, completing the square. Start by factorising out to 2. So 2 lots of x squared minus 8x. Leave the plus 7 alone for now. Then complete the square with the x squared minus 8x part. So it's going to be x minus 4 squared, subtract 16 inside those brackets. And then we can expand the 2 out. So 2 lots of x minus 4 squared and 2 lots of negative 16 plus 7. And then we can group our minus 32 plus 7 to make minus 25. So 2 lots of x minus 4 squared minus 25 is the answer. For 4b, we can just unravel the equation, add 5 to both sides, square root both sides, remembering to take the positive and the negative, and then add 1. X will be equal to 1 plus or minus root 5. For 15a, a reflection in the line y equals minus x is the matrix 0, negative 1, negative 1, 0. You can work that out, or you can just learn them. It's easier to just learn them. N squared, we've got n times m. If I carry out the matrix multiplication, it gives me a single matrix representing n squared. Minus 1, 0, 0, minus 1. That can be described geometrically as a rotation about the origin of 180 degrees. There are alternatives. Actually, there's a few other perfectly correct geometrical transformations, single ones that will do exactly the same thing. I went with a rotation of 180 degrees about the origin, because you had to pick one. Alright, question 16. We want angle OBC. It tells us that angle OBC to ODC is 5 to 3. I'll park that bit of information for now and work some other bits out. BOD, well, that's going to be twice the angle at the edge, so 104. BCD is going to be 128 because of opposite angles on a cyclic quadrilateral. That actually gives me 2 out of the 4 angles in the bottom quadrilateral. So if I subtract 104 plus 128 from 360, it gives me what the remaining 2 angles must add up to, and they must add up to 128. And so I'm going to divide 128 in the ratio 5 to 3, so that's 8 parts in total. We divide 128 by the 8 to get the size of 1 part, and then the OBC is worth 5 parts, so 16 is 1 part, 5 parts, therefore it's going to be 5 lots of 16, which is 80. OBC is 80 degrees. Okay, subtracting algebraic fractions. Always go for the lowest common multiple when working out our denominator. By factorising the first fraction's denominator, we notice we actually already have an x minus 2 in there, so I only need to multiply the second fraction by 3x plus 4 at the top and the bottom to get a common denominator. If you've just multiplied them both together, you'll end up with a horrible cubic you'd have to cancel down later on, which is not particularly fun. But now we have a common denominator. The 21x's cancel, leaving us with minus 28 as the numerator, and I'll expand the denominator back out again to write the answer in the form that the question wants. Question 18, rationalising the denominator. So multiplying by root 5 plus root 3 over root 5 plus root 3, that's a conjugate pair. And each step just being careful when carrying out the double brackets expansion. Alright, so we're going to get in the numerator a 15 plus a root 15 plus 3 lots of root 15 plus 3. And that's going to be all over 5 minus 3. Then we can collect it all together. The numerator comes out as 18 plus 4 root 15. The denominator 5 minus 3 is 2. And that simplifies to 9 plus 2 root 15. And that's fully simplified. Question 19. We're going to work out the stationary points. So the first thing I'm going to do is differentiate. So it differentiates to 3x squared minus 6x. Stationary point, the gradient is 0, so I can replace dy by dx with 0, solve the equation. So 0 equals 3x squared minus 6x. Factorise out 3x, it's a single bracket factorisation. Read off the two solutions, they are 0 or 2. We're going to do the second derivative test to determine their nature. Differentiating again to find d2y by dx squared, we're going to get 6x minus 6. When x equals 0, our first stationary point, the second derivative d2y by dx squared is going to be equal to minus 6 when I plug 0 into it. And the important fact about negative 6 is it is less than 0, therefore it tells us that this stationary point is a maximum. The y-coordinate I get from substituting 0 into the original equation, and it comes out as 5. For the other stationary point, when x equals 2, the second derivative is going to be 6 times 2 minus 6, which is 6. The important fact about 6 is that it's greater than 0, and that implies that this point is a minimum. Substituting 2 into the original equation, we get 1 out. And so the point 0.05 is a maximum, the point 0.21 is a minimum, and we're good to go. All right, question 20. I take the equation that they are asking us to solve, and I'm just going to change the way it looks a little bit. First thing I'm going to do is bring everything onto the right-hand side to make it look a little bit more like the equation of the graph that we already have. Now if I subtract a half x and add 3 to both sides of this equation, it actually turns the right hand side into the exact very form we have a graph of. So plotting the graph of y equals minus a half x plus 3 will help me solve it. I can read off on the x-axis where those intersections happen, and they happen when x is equal to negative 0.7 and when x is equal to 4.2. And so those are the two solutions to our equation, negative 0.7 and 4.2. For question 21, we're going to write everything as a single power of 2. So applying the indices rules where a to the power of b to the power of c, we times the powers together, b times c, and then I've expanded that out in one go, and then 8 is 2 cubed, so it's 2 cubed to the power of x minus 1, so 2 to the power of 3x minus 3. That means those powers must be equal to each other, and that gives us a quadratic we can solve. I'm going to equate it to 0 by subtracting the stuff on the right hand side. Notice at this point everything's divisible by 2, so let's simplify the quadratic before factorising. Factorises nicely to 2x plus 3 times x plus 1. And so we can read off the two solutions. They are minus 3 over 2 or minus 1. That's negative 1.5 and negative 1. Question 22. So simplify f of x to begin with. First thing I'm going to do is factorise the numerator and the denominator, so I can take a sine x out of the numerator, sine x lots of 3 cos x plus sine x. I can take 4 cos x out of the denominator, so 4 cos x lots of 3 cos x plus sine x, which is a really nice cancellation. I can cancel the 3 cos x plus sine x with each other, like so, and that then leaves me with a sine x over cos x, which is the tan x, and the 4's at the denominator, so it's a quarter tan x. Now we want to solve a quarter tan x equals negative root 3 over 4. So first thing we can do is multiply both sides by 4, giving us tan x equals negative root 3, and now it helps to know that therefore x is negative 60. You can add 180 to that to get to 120, and 120 is in the range that they have quoted, so x equals 120. Learn your standard trig solutions. For the sequences one, the first term is 2, so when n is 1, we'd get 2 out. Plugging n to be 1 into an squared minus 5n plus c, we'd get a minus 5 plus c. That's going to be equal to 2, because the first term is 2, and that simplifies to a plus c equals 7. The third term is 16, so substituting n equals 3, 9a minus 15 plus c will be equal to 16. we can simplify that to 9a plus c equals 31. Writing the a plus c equals 7 just below that, we can solve the simultaneous equations to work out a and c. And a comes nicely out as 3 and c comes nicely out as 4. Now we have a and c, we can work out x and y by substituting n to be 2 into our nth term formula. Now that and a equals 3 and c equals 4. When we substitute 2 into that, we get 6 out. When we substitute 4 into that, we get 32 out, and therefore x must be 6 and y must be 32. Well done if you got that. Bye.